Hello, Math Humans. We're going to do 5.3b today. We're going to do more trig equations. So our objectives are that we're going to continue working or solving our trig equations. So the first couple of examples have a unique situation in them. So we will get that as we solve. The first part of the problem says find all solutions. And notice that there's not from 0 to 2 pi. So all means that we need to consider what happens as the function repeats, since it is a periodic function. And I'm going to be given 2 cosine 3t minus 1 is 0. So just with all equations, I want to isolate as much as I can. So I'm going to get 2 cosine 3t is equal to 1. Divide by the 2, so I get the cosine of 3t is equal to 1/2. Now this is what makes one of the things that makes this problem interesting, is because to isolate this, I have to get rid of the cosine. And to get rid of the cosine, I have to do an arc cosine, because I can't divide both sides by cosine. So I get 3t is equal to the arc cosine of 1/2. And remember that this says what angle has a cosine ratio of 1/2. Well, cosine is positive in the first and the fourth quadrants. So here's the 1, this is 2, this is radical 3. So the angle is pi over 3, and then this one would be 5 pi over 3. The other thing, so I'm going to write 3t is equal to, and I'm going to do pi over 3 comma 5 pi over 3. And then because we're finding all solutions, remember that the period for cosine is plus 2 pi n. And now's when the problem gets a little bit more entertaining. So now I have to manage this 3, so I'm going to take pi over 3 and divide it by 3. And so I'm going to get pi over 9. But when I do my 2 pi over n, I also have to divide that by 3. And so one of my solutions would be pi over 9 plus 2/3 pi n. So that's kind of entertaining. So then I'll do the same thing with this one, and then it's going to be 5 pi over 9 plus 2/3 pi n. So if I am dividing both sides by 3, I also have to divide the period by 3 as well. And then these would be your two solutions. Okay? The next example is very similar. So example number 2. Again, it's going to say find all solutions. And this time our equation is 3 tangent x over 2 plus 3 is equal to 0. So the process is going to be very much the same. I'm going to get rid of this 3 first. So 3 tangent x over 2 is a negative 3. Divide by this 3. The tangent of x over 2 is a negative 1. And now to undo the tangent, I have to do the arc tangent. So it's the arc tangent of a negative 1. And this says what angle has a tangent ratio of negative 1? Well, if you think about tangent, tangent is negative in the second and fourth quadrants. And tangent is 1 when both the y or a negative 1 are the same. So this is 3 pi over 4, and then this angle over here is 7 pi over 4. So then we're going to do the same thing. The period for tangent is pi n, so I'm going to write x over 2 is equal to, and I'm going to write 3 pi over 4, 7 pi over 4 plus, and then it's going to be my pi n, because the period of tangent is pi. Well, then I have to multiply both sides by 2. So x is going to equal 3 pi times 2 over 4, which is 3 pi over 2 plus, remember I also multiply this by 2, 2 pi n, and then my other one's going to be 7 pi over 2 plus 2 pi n. And those would be my two solutions. So it's actually kind of an interesting way to solve an algebra problem. The next equation is even more fun. So for example number 3, again we're going to say find all, we love that word, all solutions. And on this one I'm going to have the equation secant squared x minus 2 tangent of x is equal to 4. The tangent of x isn't squared, So that means that I'm going to rewrite secant squared using my Pythagorean identities. Secant squared is 1 plus the tangent squared of x minus 2 tangent x is equal to 4. This is a quadratic, so I'm going to combine everything. So I get tangent squared x minus 2 tangent x minus 4 plus 1 is 0. And then I get tangent squared x minus 2 tangent x minus 3 equals 0. And now I can factor, because it's our favorite F word, and I get the tangent of x and the tangent of x. The factors of 3 that give me 2 are a negative 3, because this one's negative, so negative 3 and a positive 1 equals 0. So now I can solve my two baby equations, and I get the tangent of x is a negative 1, and then on this one I get the tangent of x is equal to 3. This is a special, so remember that tangent is negative here and here, so x is going to equal pi over 3 pi over 4 and 7 pi over 4. This one's not a special, so I'm going to get x is equal to the arc tangent of 3. And then because these all set find all solutions, okay, so I'm going to write x is equal to 3 pi over 4 plus pi n. I'll talk about why I'm not listing this one in a moment. And then the arc tangent of 3, and then plus pi n. So if I have this angle right here, 3 pi over 4, and I add pi, which is 180 degrees, I end up right here. And if I add pi, I end up right here. And if I add pi, I end up right here. So the 7 pi over 4 technically would be redundant, so that I can just write it as 3 pi over 4 plus pi n. Alrighty, let me move my paper up and we'll do example number 4. So this one's going to say, find the solutions. And we're going to go on this one from 0 to 2 pi. And I want secant squared x plus 2 secant x minus 8 is equal to 0. And again, factoring is our favorite F word. Notice that both of these are the exact same, so there's no need to use a Pythagorean identity. So I'm going to factor the factors of 8 that subtract to give me 2 are 4 and 2. The 4 is going to be positive because the middle term is positive, so I'm going to get the secant of x minus 2, and then the secant of x plus 4 is equal to 0. Okay? So this one's going to say that the secant of x is equal to 2, and this one says the secant of x is equal to a negative 4. Secant is the reciprocal of cosine, so that means that the cosine of x is going to equal a half. And then on this one, the cosine of x is going to equal a negative 1/4. Okay? This one is not a special, and by that I mean it's not a special right triangle. So on this one, I'll get x is equal to the arc cosine of a negative 1/4, and I'm going to leave it like that. This one, there's no plus pi anything because I'm only talking about one positive rotation. This one, cosine is a half. I'll do it over here. Cosine is positive in the first and the fourth quadrants. This is radical 3, so this is pi over 3 and 5 pi over 3. So my solutions for this piece are pi over 3 and 5 pi over 3. And then those would be your 3 solutions. Alrighty, that is it for today. Lucky dogs, that was a nice short video. Not even 10 minutes. I'll see you soon.